Alrighty, class. So we're going to go over lesson 5 today. And lesson 5 is basically finding the volume, and SA just stands for surface area of spheres. Okay? So we're going to just get started, and we want to start off with the definition of what a sphere actually is. So a sphere is shaped like a ball. Right? So that's like my best way to describe what a sphere is. It's just something that's shaped like a ball. There's no cornered edges. And the radius of the sphere is r. So if you look over here, right, so I'm just going to write that in. Ball. I gotta turn that off. Ball. There's no round edges, see? So it's just a circular shape, right? No round edges. And if you take the measurement from the center of the sphere to the end, that'll give you the radius, right? So anything that's like a basketball, a tennis ball, right? A ping pong ball, anything that's shaped like a ball. Okay, I'm not even gonna bother writing this in. Alrighty, so moving on, just gonna get rid of that. The volume of a sphere is represented using the formula for, so volume is equal to 4 pi r cubed divided by 3. And the surface area, or SA, is equal to 4 pi r squared. So if you want to know where these formulas actually come from and like the derivation of why we have them, there's some really good YouTube videos here. So if you go into your D2L and you click on your worksheet, you can actually hyperlink. They're hyperlinked to you. So there's some good video links there. So the one that I really want to talk about, if you notice, pi r squared is just the area of a circle, right? So if you were to theoretically go in and take, like look at a ball, it's basically the surface of 4 circles put together. And these videos do a really good job of explaining that. So I won't go into it too much. Okay? So example 1, we're just going to go in and start doing some examples. So it says example 1, determine the volume and surface area of the following spheres to 1 decimal place. So I already told you that it's only to 1 decimal place, right? So make sure you look into that, right? And then we're just going to move on and try doing this. So let's find the volume and surface area. Before we even do that, let's figure out what our radius is. So our radius is anything from the center to the end. So our radius here is equal to 8 centimeters. Right, we didn't really need to do any extra work there. So our volume is equal to, and I just went back to the top and I found out that my volume is equal to 4 pi r cubed divided by 3. Right, so if I go back up here, 4 pi r cubed divided by 3. Right, so I'm just going to go in and I'm going to put in the variables that I have. I have 4 pi. Make sure you're using the pi button and not your 3.14 because we're using the pi button now. You should have a scientific calculator. 8, which is our radius, to the power of 3 divided by 3. So we're just going to do this. 4 times pi times 8 to the power of 3. 8 to the power of 3 is 512 times 4 times pi is going to be 6,433 981,982 divided by 3. And I'm going to use the A and S feature on my calculator and just divide it so that I have maximal amounts of decimal places in there, right? And my answer is going to be 2,144.660585. And I'm just going to round that to 2,144.7 centimeters cubed, right? And that is my overall answer for volume. So I'm just going to go back here and change this. And I'm always going to want to write volume equals. Okay, so volume equals that. I'm going to go in and I'm going to do the same thing, but for surface area. So surface area, if I go back up here, is equal to 4 pi r squared, right? So I'm going to go 4 pi r squared, right? Surface area is equal to 4 times pi times 8 squared 8 squared is 64 times 4 times pi. 64 times 4 times pi is going to be, I'm just going to go in and write that step in for you, is going to be 804.247719. So I'm just going to put it as 0.2 centimeters squared. Make sure you put in your units. That's communication marks. Okay, and that's my answer. So the volume is that and the surface area is that. So let's move on to B. So pause this video and try doing it yourself. And before we even get started, this entire length, right? So this entire length of the sphere is, like across, is 12.4. So if you want to find the radius, you need to make sure you go halfway through. So pause this video, try doing it yourself, and I'm going to take it up. All right, welcome back. So let's start volume. We know our volume is going to be 4 pi r cubed divided by 3, right? We got to find our radius first. Our radius is going to be equal to 2.4 divided by 2. So you're going to do 2.4 divided by 2 equals r. So we have 12.4 divided by 2. 6.2 equals r, right? So let's go plug in that r value. V equals 4 pi times 6.2 cubed divided by 3. Let's do the top portion first. 6.2 cubed is going to give me 238.328 times 4 times pi, right? It's going to give me 2,994.917976, blah, 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 blah. Right? So I'm just going to round this up to, for the purposes of writing it down, but in my actual calculator, I'm just going to plug in the ANS feature, and I'm going to get volume is equal to, I'm going to just divide that by 3, 998.3 centimeters cubed, because it's 305, so I'm just going to leave it as 3. And that's my volume. Same thing with surface area. Surface area is equal to 4 pi r squared, right? So I'm going to take 4 times pi times 6.2. We're going to square the 6.2. 6.2 squared equals, so I'm just going to go in, I'm going to do 6.2 squared, and I like to put these all into my calculator at the same time, just because then I have the most accurate number and I don't have to like type in all of those numbers again. So I'm left with 483.05, so it's going to be 483.1 centimeters squared is equal to surface area. All right, and that's my answer for those two. All right, so we're going to move on now. This says the tennis balls are each 8 centimeters in diameter. So 3 tennis balls, 8 centimeters in diameter. If you've looked at your assignment, this is an important one to look at. 8 centimeters in diameter are stacked in a cylindrical container. What is the volume of the empty space? So that's what we're looking for. What's the volume of the empty space? So I'm just going to go in here with my green marker and show you what we're looking for. We're looking for this stuff right here. Right, so I'm just going to change that. So right here, this space right here. So let's think about this logistically, right? We're looking for all these empty spaces. The best way to go about approaching this problem is saying, okay, the volume of the spaces, the empty spaces, is basically going to be, if you took the entire volume of the cylinder, right? So you took the volume of all the cylinder, and then you took the volume of each individual ball and subtracted it, right? Volume of the balls. right? Then you will get the volume of the space because that's whatever's left over. So once you put the balls in, whatever's left over is the volume of the space, right? So let's just put in what we know. The volume of the cylinder is just the volume of a cylinder, which is pi r squared times the height, right? Minus the volume of the balls. There's 3 balls, right? And they're spherical shapes, so the volume of a sphere is pi r cubed divided by 3. So that's what I'm looking for. This is the equation I'm going to use, right? Let's go in and start filling some gaps. So first things first, I need to find the height, right? How can I find the height if I'm given this? I know that each of these balls is 8 in diameter, right? 8 centimeters in diameter, so from top to bottom. I'm going to go and put some more in, right? And I know that when you stack them on top of each other, they fill the entire length of the container. So when stacked on top of each other, it's 8 plus 8 plus 8 will give me the height, right? So that'll give me the height. And I'm just going to put this in lowercase. So height equals 24. 8 plus 8 plus 8 is 24 centimeters. I also know across, because the diameter is the same up and at the top and the bottom, across it's also 8 centimeters, and they seem to be fitting end to end as well. So the diameter of the cylinder, they're fitting pretty snug, is also 8 centimeters. Okay? So let's find the volume of the cylinder, right? And I'm going to say the volume of the cylinder, I'm going to put in this blue marker, right? And then the volume of the other thing I'll put in the volume of the balls I'll put in this marker. Okay, so the volume of the space is equal to pi times the radius, which is radius is equal to diameter divided by 2. So 8 divided by 2, 4 squared, times the height, which is 24, right? Minus 3, because there's 3 balls in there. 3 times 4 pi, r is still 4, cubed divided by 3. All right? So that is my formula, and we're just going to go in and start solving stuff. So let's do 4 squared is 16, right? So this is going to be, and I'm just going to start doing them in the same color. So pi 16 times 24 minus, I can cross these 3's out, and I can say 4 pi. 4 cubed is just 4 times 4 times 4, which is 64. Right? And let's solve. Let's do this. So we're going to do, and you could have theoretically done 4 pi 4 times 4 cubed divided by 3 and then multiplied that by 3. It's up to you, whichever way you want to do it. You don't have to do it this way. This is just how I see it, and it's easier for me. So I'm going to do pi times 4 squared, pi times 16. 16 times pi times 24 is going to be 1206.3715. So I'm just going to write 1206.371, right? Minus 64 times 4 times pi, right? Which is going to be 804.258. And I'm just going to subtract those. 12. So I get about 402.123. So I'm going to write 402.1 centimeters cubed because it asked for only one decimal point. So the volume of the space is equal to 402.1 centimeters cubed. So I'm going to write therefore the volume of the space is 402.1 centimeters cubed. All right? So moving on, we're going to determine the surface area, or we're going to determine the radius if surface area is 452.4 centimeters cubed. And I know this seems really confusing, but let's just take it step by step. So the radius is just a spot from the middle to here. I know that surface area is equal to, and I'm just going to change this color to this one. Surface area is equal to 4 pi r squared. Right? So let's just start plugging in the numbers and then we can just solve for r. Right? So my surface area was 452.4 is equal to 4 pi r squared. And now it's just you got to rearrange your equation to get the r by itself. We can get rid of the 4 pi by dividing both sides by 4 pi. Whatever I do to one side, I have to do to the other. So let's do this. 552.4 divided by 4 pi is going to give me 36.000848. So I'm just going to write 36.00 equals r squared. If I want to get the square if I want to get the r by itself, I got to square root this side to get rid of the square. Got to square root this side because whatever I do to one side, I have to do to the other. 36 square root is 6. So 6 is r. Therefore, the radius is 6 centimeters. Okay? And that's pretty easy. And if you actually went back and plugged it into the formula, if you plugged it back into 4 pi r squared, you would get the same surface area. Okay? And the last example we have here, and we're almost done, is calculate the volume and surface area of the sphere below. So, one thing you need to notice is we're missing a whole quarter of the sphere. We took out a chunk of it, right? So we just need to recognize that this is 3/4 of a sphere. So we're missing a good chunk of it, which means that when we go to find the volume and the surface area, we need to find three-quarters of the volume, which is easy. Multiply volume by 3/4. Right? If I want to find out how much 3/4 of something is, I just multiply it by 3/4. So let's do this. My volume is equal to 3/4 multiplied by 4 pi r cubed divided by 3. That's just my equation, right? 4 pi r cubed. We know that the radius is 7 centimeters. So let's take the radius from here to here, right? The radius is 7 centimeters. So let's just put that in. V is equal to 3/4 times 4 pi 7 cubed divided by 3. Now, you have two options. You can go in, solve the bracket first, then multiply it by 3.4, also acceptable. But I'm just going to go in and I notice that this 3 and this 3 cancel out. And I know that this 4 and this 4 cancel out. So I'm left with volume is equal to pi times pi times 7 cubed. So volume is equal to 7 cubed is 343 times pi is equal to 10,077. So 1077 77.56, so 0.6 centimeters cubed. And that's my volume. Easy peasy, lemon squeezy. Surface area is a little bit more complicated. In theory, right, you would just do surface area times 3/4. right? But what actually happens, so surface area is going to be 3 over 4 because we took that chunk out. But we need to do a little bit of extra work here. It's not that easy. Basically what happened is when we took out that chunk, you actually exposed 2 more surfaces. So now you have this surface and you have this surface to account for, which are 2 semicircles. You have a semicircle here, you have a semicircle here, right? And they're 2 semicircles with the same radius, because if you went across from here to here, you would have 7. If you went across from here to here, you would have 7. So basically, what you did was you added 2 orange half circles. So you added, or 2 half circles. We added 2 half circles, or 1 full circle, right? So let's just put in the formula. So we had SA is equal to 3 over 4 times 4 pi r squared plus, right? 2 half circles is just 1 whole circle, and the area of 1 whole circle is just pi r squared, right? So I'm going to do some simplifying, and I know some of you are probably seeing a pattern here, but I'm going to cross that 4 out, right? And I'm left with surface area equals 3 times pi r squared plus pi r squared. These are what we call like terms. So we can actually add the 3 and 4 together. Oh my God. It came back to haunt us. If you didn't learn it the first time, you'll learn it now. So you'll be left with 4 pi r squared, which is funny because that was our original formula in the first place, right? That was our original formula in the first place. So we didn't actually have to go through all of that, but I wanted to show you why it was still that formula. Okay, so then I'm going to do surface area is equal to 4 pi r is just 7 squared. So 4 pi 7 squared is 49. Right, I'm just going to put this into my calculator. And like as you're going through this, make sure that you can actually put it into your calculator and that you're getting the right answer. So I have 4 pi times 49 is going to give me 615 times 752. So it's going to give me 615.8 centimeters squared. That's my surface area. And I'm just going to go in, I'm going to box that in, right? And of course, I'm going to write a statement, and I'm going to say, right, therefore, volume of the sphere is 1077.6 centimeters cubed, and surface area is 615.8 centimeters squared. And make sure you have the right units and all of that great jazz. Okay. I want it to be a clap. And that's it. Your homework is listed here. So it's going to be page 470, questions 1 to 4, 5A, B, 7, and 9A. The questions are in your textbook, and the answers are actually in the back. So make sure you check your answers. Okay. All right.